Welcome to this video. In this video, we are going to learn about implementing Singleton Design Pattern in C#. Okay, so the contents of this video. First of all, we are going to look at the Singleton Design Pattern. We are going to look at its key characteristics and how we can implement this in C#. And last but not the least, we are going to look at its pros, cons, and when to use it. Okay, so what is a Singleton Design Pattern? A Singleton Design Pattern ensures that a class has only one instance and provides a global access point to it, meaning that you cannot create multiple instances of it. There is always a one instance that's available throughout your application. What is its purpose? I mean, it's useful for managing resources, logging, caching, and thread pools, among others. Basically, controlling the object creation. There are certain use cases where you can use this Singleton design pattern. For example, database connections, configuration settings, logging. If you just think, you don't need to create multiple instances of any class when you are either using database connections or maintaining the configuration settings, or you might have created your own loggers. We'll look at the key characteristics of any Singleton design pattern. So single instance, it always ensures there is only one instance. As I said earlier, that the pattern guarantees that a class has only one instance during the life cycle of an application. Okay, and global access point provides a state point of access for different parts of an application to refer to the same instance. And on top of it, it provides constructor control. What you need to do is, when you are creating a Singleton design pattern, you need to ensure that your constructor is private and there is a static instance folder. So here in the private constructor, so once you make your constructor as private, so it restricts the object instantiation from outside the class. And on the other hand, the static instance holder, which uses a static variable to hold the single instance of the class, ensuring a centralized control. Now, you also need to think about concurrent access controls. So there are scenarios like multi-threading control, thread save mechanism. What happens if there are multiple threads try to access the same Singleton instance? Let's say you spawn an application and there are multiple threads trying to just call your instance variable, the static variable that holds an instance. So that's not a thread save. So what might happen is you might just end up creating more than one instance, and each thread might end up working on its own instance. So the best way is we need to ensure that it's thread safe. And how do you do that? We need to ensure that we implement proper locks around object creation. Now, in this slide, we are going to check how we can implement Singleton in C#. Okay, so the a static instance variable, which I discussed earlier, will hold the instance. That's going to be a single instance, right? Here, as you can see, that we have declared a class Singleton, and we have declared a private constructor, which will ensure that there is no object creation, and it always ensures that there is only one instance. So the instance can be created only from within the class, and that's totally controlled. So nobody can call new Singleton, because once you mark this class as once you mark this class constructor as private, you definitely cannot instantiate it. Okay. Now there was another characteristic that we discussed, that having a static variable that will hold the instance of this class. As you see that we created a variable private static Singleton, which is nothing but the same class instance here, the variable here. Here, what we are doing in the static method, so we check for the instance variable. If it is null, then we are going to create Singleton. Now, so this is our basic approach. As we just discussed, that what happens in a multi-threaded environment. This is not thread safe. Just imagine that there are two threads calling this get instance, and they might just happen to create two different instances. So what we do is we make use of a lock. So here, the lock will ensure that it prevents multiple instances from being created in a multi-threaded environment. So that's how lock helps us here. So because meaning that, let's say there is one thread that has called this get instance. And once lock is executed and while thread 1 is being executed, so it ensures that the thread 2 cannot go and call this unless thread 1 is finished. Now, once thread 1 is finished, the thread 2 comes in, it checks the instance is not null because earlier with the lock we ensured that thread 1 and thread 2 cannot happen to access this part of code simultaneously. Now with this lock, we ensured that we synchronized the access to this particular code with the lock. Okay, so this helped us with resolving the issue where multi-threaded in the multi-threaded environment. Now there is another thing that's called lazy initialization. So here, uh, I mean, you can use a lazy initialization to ensure that single instance creation only when needed. So which ensures performance and thread safety. So what you need to do is you need to mark your read the static variable with the lazy. So this ensures that only when the singleton is being used, then only we are going to uh, create the instance, meaning that unless the variable is used somewhere, the instance is not going to be created. So that's the benefit with a lazy initialization. Okay, now we are going to evaluate the singleton pattern pros and cons. So the pros, as we discussed, that of course it ensures a single instance, meaning that we save memory by preventing multiple instances, useful for managing shared resources. And so in the shared resource management, I mean, this is quite effective in managing caches, logging services, various configuration settings. So, I mean, if you just think from practical point of view, like you can implement your cache, which effectively uses a singleton, and there are multiple points in the application that's accessing the same cache with a singleton, and the same goes with logging and the configuration settings as well. And in the cons, we can see the global state issues and testing difficulties. Okay, so what happens is when you are creating the singleton design pattern, I mean, it's not that flexible and it's quite tightly coupled, and it makes testing quite difficult because uh, you cannot easily mock things when you are creating the singleton instance. So you cannot, it will not be that easy to write the unit test, and that's how it makes little things little difficult. And even from my past experience, I have seen when you implement something as a singleton design pattern, I mean, it becomes quite complex to write your own unit test because it's not that flexible enough because you need to ensure that somehow you are able to inject things and mock things. There's some difficulty over there with the singleton design pattern. So here we'll also look at when to use this singleton design pattern. So where when you want to provide, I mean, when you want to have controlled resource accesses, and so here like when a single instance is required for logging, caching, configuration, and control access is necessary, then you can go with the singleton. And but this should be definitely be avoided when high testing and design flexibility is required. So throughout this video, we have seen what is singleton design pattern, its characteristics, where we discuss about the private constructor, a static variable which is holding the instance of the instance, and we have also seen where the use cases where we can use a singleton design pattern and its pros and cons. So I hope I made it very easy for you to understand the singleton design pattern. If you understood something about this, just don't forget to like this video, and just if you have got any feedback, you can drop in your comments. I really appreciate it. Thank you very much.